Okay, here we are in our second section, 1.2. Again, we're going to talk about derivative. And I want you to get familiar with the phrase rate of change and attach it to derivative. Any kind of rate of change is your derivative. And the book's going to ask questions like how fast, because you need to think of fast as rate. How fast is the function changing? And by function, we mean y value. Okay, quick review of some function terminology before we get started. Okay, remember function terminology, we're just replacing the y with an f of x. The function of x equals, let's say, 6x squared plus 2x plus 1. And if I ask you to find something like f of 3, hopefully you remember from algebra that just means substitute the 3 in for the x and work it out. So 6 times 3 squared plus 2 times 3 plus 1. Order of operations says square first. 9 times 6 is 54. 6 and 1, we are going to get 61. Okay, the next thing I want you to do is familiarize yourself with the general equations. Do not write these down. On page 6 in your book. And I'm going to put that up and we're just going to talk through them a little bit just to remember some things from algebra and algebra 2. Okay, starting with the linear function. Hopefully you remember that's just mx plus b. It's linear because the exponent on the x is a 1. Quadratic, your highest exponent on the x is an x squared, and it can have the other two terms or not. The polynomial functions, a quadratic is a special polynomial, because all a polynomial function is terms added together where the exponent on the x can be anywhere from 1, 2, 3, 4, all the way up to whatever. A power function now is just a single term. It can't have anything added to it. So a power function is a special polynomial function. It's just x to any power you want. Could be cubed, squared, first, and it's just one term. The exponential function has the x up in the exponent. So this could be something like 2 to the x, or 3 to the x, 4 to the x. A rational algebraic function is a polynomial divided by another polynomial. Absolute value functions just have to have an absolute value in them somewhere with the x terms inside. And then our last ones are the trig functions. And there are 6 of them: cosine, sine, tangent, cotangent, secant, and cosecant. The book also refers to them as circular functions. I know we only talked about them as trig functions. Okay, so just a little refresher there. And now we start the new stuff. Our first example I'm just going to give you an equation. Well, not an equation, a graph. And our function looks like this. Okay, I'm going to pick out 3 points on this function. I'm going to pick A to be right here, B to be right here, and C out here. I'm going to ask you 2 questions about each point. At each of the x values, I want you to be able to tell me the first part of the question is y, the function, increasing or decreasing? And then after that, I want you to tell me, is the rate that it's increasing or decreasing fast or slow? Okay, so for point A first, we'll start there. Okay, our first question we want to decide, is the y value increasing or decreasing? And what we're talking about is as you pass through this point, is it increasing or decreasing? Well, if I walk to the left, I'm increasing. If I walk to the right, I'm decreasing. So which one is it? Well, you read graphs just like you read words, from left to right. So I want to start on the left side of A, which is above, and as I walk to the right, I am decreasing. So at A, the function is decreasing. Now, just using common sense, do you think this is a fast or slow rate here? Well, what part about this graph is going to tell you that is how steep it is. The steeper it is, the faster it is. Just like skiing. Big steep hill, fast slope. Shallow hill, slow. So this rate here is going to be fast. That's a very steep hill to ski down. So think about skiing when you're answering fast and slow. At B now, B is kind of a trick question when I say is y increasing or decreasing, because I wanted it to be right at the vertex down here, the minimum value. And if you're at a minimum, you're going down before it and up right after it, because that is the lowest point. It doesn't increase or decrease. It doesn't do anything there. So it's a neither. So can I answer the question of fast or slow? No, I can't. If it's not increasing or decreasing, it doesn't have any rate there. And then point C, over here. Increasing or decreasing? Well, as I go from left to right, I can see I'm going uphill slowly. So it's increasing, and it's kind of flat through here. I'm going to say slow. And I'll try to keep them pretty, because sometimes you get something in the middle. Oh, should I call it fast or slow? I'll stay away from that. So the steeper it is, the faster it is, the shallower it is, the slower it is. So you'll have some problems like that on your homework. Then you'll have some story problems where they just give you a table of points, like this next one. Example 2. Okay, we have a mass that is bouncing up and down on a spring. Hanging from the ceiling. And when I'm going to define y is going to be the feet from the ceiling, the distance in feet from the ceiling. And t is going to be the time in seconds since the mass was stretched and released. So here's a picture of what you've got. You've got your ceiling, and then you've got your spring, and then you've got your mass attached to the spring. Pull down on the mass, let it go, and you can tell it's going to bounce up and down. And y is going to be the distance measured here between the mass as it goes up and down. Distance from the ceiling, and our floor is going to be down here. Okay, so here's our table of points. Time, and y is the distance from the ceiling in feet. So we're going to start this at 0.2 seconds after it was released to 0.3, 0.4, 0.6. Oops, 5, I can count. 0.6, 0.7, 0.8. Okay, the distances, 3.99, 5.84, 7.37, 8.00, 7.48, 6.01, and 4.16. Okay, my first question, can you tell how fast y is changing at time equals 0.3? Okay, how fast? That's your rate of change. That's our derivative. And yesterday we did derivative with a 2-point table. We would take like 0.3 and 0.31 or whatever. But today we're going to get a little more accurate. We're going to look at what's happening right before the 0.3 and right after the 3. And we're going to average that together to see what's happening as we pass through. So today, to do derivative, we're going to use what's called a 3-point table, where I'm first going to do what's happening right before and at, and then I'm going to do what's happening at and after my given t-value. So I'm going to do change in y over change in x, because that's what derivative does. It divides our variables. So I'm going to set up the first one, 5.84 minus 3.99. Change in time is 0.3 minus 0.2. That's 1.85 over 0.1, 18.5. Okay, and we should get used to putting units on these with the story problems. And I did the change in y. That was the change in feet. So there's 1.85 foot change over, and then this was a change in time, change in seconds. So it's feet per second that I just figured out, which is a rate. Now, from the 0.3 to the 0.4, I'm going to go 7.37 minus the 5.84. Oops, sorry, that happens. 7.37 minus the 5.84 over the 0.4 minus 0.3, which is going to give me 1.53 over 0.1, and that will be 15.3 feet per second. Okay, and now I know what's happening as it comes up to the 0.3 and right after the 0.3. Now I'm going to average those two together to see what's happening as I pass through the 0.3. So averaging is just add these up and divide by 2. So 18.5 plus the 15.3 averaged together is a 16.9 feet per second is the rate at which y is changing at 0.3, an estimate for it anyway. Okay, after that, is the function increasing or decreasing? Increasing. I know the rate. Is it increasing or decreasing at time equals 0.3? Well, there's a couple things you can do. I could look at the graph, which I don't have the graph of, but I can tell as I go from left to right, I'm going 3.99 to 5.84 to 7.37. I can see that's an increase. Or all I've got to do is look at the sign on this. This came out positive 16.9. So if this is coming out positive, I know it's increasing. Same thing I got over here if I was to look at the graph and draw a smooth line through these points. It would be going uphill. Okay, now the tough one. Is the mass bouncing up on its way up, or is it going down? Is the mass moving in an upward direction toward the ceiling, or is it bouncing down towards the floor? Okay. Sorry about that again. So So I'm asking for the last question, is the mass moving up or down? Well, let's think about what y was defined as. I know from part B that y is increasing at 16.9 feet per second. Well, y was the distance from the ceiling. Well, if my distance from the ceiling is getting bigger, I know that that mass is on its way down, because that's the only way to increase the distance up there. So the mass is moving down. Okay, kind of some backwards thinking there. People automatically want to think, oh, if it's increasing, it's got to be going up. Nope, not the way y was defined. Y was defined as the distance from the ceiling. The only way for that distance to get bigger is for this mass to be on its way down to the floor. So be careful on those. Okay, I want to try one more spot on here. I'm going to squeeze it in over here, D. How fast is the mass moving at time equals 0.6? And again, when you've got a table of points like this, the most accurate, the best thing you can do is to do that 3-point table, and that's what you're going to practice today. So 0.6 is my center, so I want to look at what's happening before and after. So doing the before first, always start here with the 0.6 minus what's above. So the 7.48 minus 8, 0.6 minus 0.5. It's going to give me a negative 0.52, 0.1, negative 5.2 feet per second. Got a negative value this time for the rate. We'll talk about that at the end. Doing the after, I'm going to go 6.01 minus 7.48 over 0.7 minus 0.6. That comes out negative 1.47 for a negative 14.7. That will be feet per second on both of these. So now I want to average those together to see what's happening. So I've got the before, I've got the after. To estimate what's happening at that point, we're going to average. So negative 5.2 plus negative 14.7, average, divide by 2. I come up with negative 9.95 feet per second. Don't forget labels. You'll be losing points if you forget your labels on the quiz and the test. Okay, that tells me a couple of things. First of all, that the function is decreasing because of the negative. So y is decreasing. Maybe I shouldn't use the arrow because that's confusing. Y is decreasing. That means y was the distance from the ceiling, and that is decreasing. Decreasing means it's getting smaller. And the only way for this distance to get smaller is for this mass to be moving in an upward direction. So y is decreasing. Mass is moving up. Okay. So you'll have a couple story problems today, or on this assignment. And then the last type of problem you're going to have has to do with no story problems, just an equation with it. So number 3 is your number 16. I'm going to show you that real quick. So when you get to the set of problems, right here, starting at 15. It says, tell the type of function, whether it's linear, quadratic. That's that table of functions I showed you at the beginning, so you can flip back to that page 6 to answer that question. Find f of c. That's just plug your number in the function and see what the function comes out to be. Then here's where the calculus comes in. Tell whether f of x is increasing or decreasing at c and at approximately what rate. That's our derivative. That's going to be our 3-point table. So I would do the rate first. Then when I see what it comes out, whether it's positive or negative, I'll be able to tell whether it's increasing or decreasing. So 3 parts to these. So number 16 gives us the equation f of x equals negative x squared plus 8x plus 5. And at c equals 1 is what I want the rate. Okay, first question, what kind of function is this? I don't need to look back at the table to know when I've got an x squared that it's a quadratic, but if you need to look back, you look back. It wants me to find the value of the function at that given c value. So that's asking me to find f of 1. So I'll plug 1 in there. So that's the opposite of 1 squared. That does not mean negative 1 squared. You do the squaring first, then take the opposite. Plus 8 times 1, plus 5. So this will give me negative 1, plus 8, plus 5. That'll be 7 plus 5 is 12. And then C, I want to know whether it's increasing or decreasing at what rate. Okay, anytime I see rate, I'm going to think derivative, 3-point table. So, and it's at c equals 1. So, I want to make a 3-point table. I want 1 in the middle of the table, and I want to look at what's happening right before and right after. Now, how far before and how far after, it doesn't really matter, but let's stick with, let's go 100th. 100th is a good one. So let's go 0.99 and 1.01. So to get the, well, I know the 1 value, it's 12. To get these other two, I could plug 0.99 in here, crank through it, and then plug 1.01 in here. It's much quicker to use the table feature on your calculator. So get used to this. We'll go to the y equals. Oops. Clear this out. I think I already have it typed in here. Negative x squared plus 8x plus 5. I'm going to go to the table. Set. I want it to start at 0.99. And I want the increment to be 0.01. So I've got it all set, and I'll just go look at the table. Okay, at 0.99, I see 11.94. But be very careful. You want to put the cursor on there, because remember, this chops the numbers off. Look at down here, I've got all the decimal places, because you want to carry out quite a few of them. I mean, this one only has 4, but if it ran on, I'd carry out about 6 of them to get the answer as accurate as you can. So 11.9399. I've got the 12, and then put the cursor on there. I see I've got 12.0599. Okay, and I saw the 12.06 there, so be careful with that. I'll zing you on that if you're not using all the decimal places. Okay, and now the rate, I just got to do my change in y over change in x. Here and here. So that's 12 minus 11.9399 over, I know this change is 0.01. And then here, 12.0599 minus 12 over 0.01. This one I can do without a calculator. 0.0599 over 0.01 is going to give me 5.99. This one, I did pick up a calculator. I got 0.0601 over 0.01, which gives me, move it over to 6.01. Okay, now I average these two together. I don't really need a calculator here. I know it's halfway between 6.01 and 5.99, but if you want to write it out, in case you're looking back, 6.00 is my rate. And I can't put any units on here because they didn't tell me what x represented it or what the function represented. So that's as much as I can do for the rate. Okay, so it's mostly just 3-point table today. Your assignment tomorrow is going to be on page 10, 1 through 10 all. Again, this is your in-class work tomorrow. If you want to get started on it ahead of time, you can. 11 through 17 odd, 18, 23, and 25. Oh, it's still going up here.